We have learned about quadratic functions and absolute functions. It is good time to combine them and then find their derivatives. So the question before us is, given f of x equals to absolute value of x squared minus 1, we need to sketch function f of x, find derivative of f of x, and sketch derivative of f of x. How are you going to do it? Well, we know individually x squared minus 1 is a parabola which is translated one unit down, and absolute function is always positive. Now, taking that into consideration, let us sketch the function first. Okay, so let's say that's our coordinate axis, x and y. So that becomes a coordinate plane. Now, so x squared is a parabola which is shifted one unit down. So we can just draw a parabola which kind of shifted one unit down, right? So that becomes a parabola. Now here the vertex should be at minus 1 and these intercepts are at minus 1 and plus 1, and that is the parabola which is x squared minus 1. Now, what is absolute value? Absolute value is positive value, it's never negative, right? So basically, if you see from left to right, x squared minus 1 is positive, so the absolute value will be exactly same. So let me just over it draw in a different ink. So this is my function which I am drawing as absolute value of x squared minus 1, right? So that is the first part which I'm trying to do, sketch the function absolute value of x squared minus 1. Now at this point we have negative going up to x equals to 1. So absolute value will flip it over the x-axis. X-axis acts as a mirror, right? So what we get here is kind of flipped parabola like this. Do you see that? So that part becomes negative of x squared minus 1. And from 1 to infinity, since x squared minus 1 is positive, absolute value is exactly same, right? So that is the sketch of our function f of x, which is absolute value of x squared minus 1. So we have done the first part. Now let's move on to the second, which is find derivative of f of x. Now it's a good idea to write this function as a piecewise function. You see, there are a couple of different pieces joined together. So let's write down this function as a piecewise function. So what we can do is we can say, well, f of x is equals to absolute value of x squared minus 1, but this is equal to different pieces, right? So let me just say what different pieces. Let's start with the leftmost piece. From minus infinity to minus 1, it is same as x squared minus 1, right? So I'll write x squared minus 1. This is when x is less than minus 1. Now at minus 1, what happens? Well, at minus 1, it is 0. So let me write 0 for x equals to minus 1. From minus 1 to plus 1, the function x squared minus 1 was flipped, right? So it is negative of x squared minus 1 when x is between minus 1 and plus 1. And at 1 the value is 0. So let me write x equals to 1, the function value is 0. From 1 to infinity, absolute value is same as the function itself, I mean x squared minus 1. So we can write same as x squared minus 1 for x greater than 1. I think we can use this space here to write down the derivative. So I'll write f dash of x here, right? And I'll write down derivative in this column. Okay, it'll mess up a bit, but I think it will give us a better picture. Okay, so let me draw some guidelines. Okay, now let's start with the leftmost portion, which is x less than minus 1. x square minus 1 derivative is 2x, right? So we get 2x here. For 0, at this point, well, it's a corner, right? So it does not exist. So we'll write D and E for does not exist. Now in this portion, the function is minus of x square minus 1. So derivative will be minus 2x. So we'll write minus 2x. So that's the derivative, okay? At 1, it is undefined since it's a corner, right? So we'll say does not exist. And beyond 1 is x square minus 1, the function. Derivative is 2x. So we'll write 2x here. So that is the derivative for us for different intervals. So that is our part B, right? To sketch, it's a good idea to get some points. So I'll again make some guidelines just as I did before. So this time we are splitting the function at minus 1. So this is a very important guideline. We are not using actual grid here. So rough sketch, I hope you are getting what I'm trying to do, right? So I'm just making few guidelines so that we can get fairly accurate diagram, right? So, well, we say this is 1 for us, right? And let's say this is 2 and minus 1, minus 2, okay? Start with the leftmost portion, which is beyond or between minus infinity to minus 1. We have a line with a slope of 2 positive, 2x, right? So 2x is from minus infinity to minus 1. So what is the value at minus 1? If I put x as minus 1, what do I get? Minus 2. So I should have a hole at minus 2, which is here, right? So that point is a hole, right? At minus 2. This is at minus 2. Slope is 2, so it's a straight line from minus infinity to minus x, right? In this interval. So I can draw this line with a slope of 2. So it's kind of like this, correct? So that becomes the first part. Now the second part is at x equals to minus 1 does not exist. Well, that's clear. So I've drawn a hole here, right? Perfect. Now between minus 1 and 1, the slope is minus 2, right? That's the derivative is minus 2x. Now let's plot some points. If I put x as minus 1 here, what do I get? Minus 1 times minus 2 gives me plus 2. So at minus 1, the value should be plus 2. So I'll make a hole here since that point is not included, right? When x is 0, minus 2x will be 0. So that is a point on the graph, right? And when x is 1, it should be minus 2. So we have, okay, this line is not that straight. Anyway, we have a hole somewhere there, right? But to get this hole, it's better to join these points. So let's join them. Okay, so that becomes a hole, right? So this is, we will say, a hole at 1. So now if it is beyond 1, derivative is 2x. That means a line with a slope of 2. But where does it start from? If I put 1 here, I get 2. So it starts from 2, but definitely not including 2, right? So this is a hole and the same kind of slope. Do you see that? So that becomes the sketch for the derivative, correct? So that is how we can sketch the derivative. Go through small steps as we went here, right? The function was x squared minus 1 absolute value. We started with x squared minus 1, absolute value was superimposed on it, function of function. So we made it positive, reflecting on x-axis for the negative half. And then we actually defined piecewise function equivalent to the given function. And all these things helped us to sketch and to find the derivative. Now it's very critical to split your function in a different way. And I think this point, when we are writing x equals to minus 1 and plus 1, the value is 0, really helps to solve this problem. And that is, I think, the critical thinking which is required to be done in solving these kinds of problems. I hope you learn and appreciate